Outer planets. Jupiter is the largest planet in our solar system, with a diameter of 86,881 miles, 1,039,822 kilometers, more than 11 times the diameter of Earth. It is primarily composed of gas, mostly hydrogen and helium, with a small rocky core at its center. It rotates very quickly, completing one rotation in just under 10 hours, making it the fastest rotating planet in our solar system. Its strong gravitational pull has helped to shape the orbits of other planets and objects in our solar system. Jupiter has a very strong magnetic field that is about 20,000 times stronger than Earth's magnetic field. This field traps particles from the solar wind, creating intense radiation belts around the planet. Jupiter has at least 79 known moons, the four largest of which are called the Galilean moons: Io, Europa, Ganymede, and Callisto. The Great Red Spot is a massive storm on Jupiter that has been raging for at least 350 years. The red spot is larger than the size of Earth. The Juno spacecraft is currently orbiting Jupiter, studying its atmosphere, magnetic field, and interior structure. Saturn. Saturn is the sixth planet from the Sun and the second largest planet in our solar system, and is known for its spectacular system of rings, made up of millions of individual particles of ice and rock. These rings are approximately 175,000 miles, 282,000 kilometers in diameter, but only about 30 feet, 10 meters thick. Saturn is a gas giant planet, meaning it is primarily composed of hydrogen and helium with a small rocky core at its center, and has at least 82 known moons. Saturn is much less dense than Earth, and if you could find a body of water big enough, Saturn would float on it. Saturn's atmosphere is known for its complex cloud patterns, including a hexagonal pattern around the planet's north pole. The length of a day on Saturn is about 10.7 hours, and it takes approximately 29 Earth years for Saturn to complete one orbit around the Sun. Titan, Saturn's largest moon, is the only moon in our solar system known to have a dense atmosphere, and the only other place in our solar system besides Earth where there are known to be bodies of liquid on the surface. That's actually pretty cool. Uranus. Uranus is the seventh planet from the Sun and the third largest planet in our solar system. It is an ice giant planet, meaning it is primarily composed of water, methane, and ammonia ices, with a small rocky core. Ammonia smells terrible, by the way, so it's a stinky planet. Meaning it is primarily composed of water, methane, and ammonia ices, with a small rocky core. Uranus is known for its extreme tilt, with an axial tilt of about 98 degrees. This means that the planet essentially orbits the Sun on its side. Uranus has 27 known moons and has a faint ring system made up of dust and small particles. The atmosphere of Uranus is primarily composed of hydrogen and helium with a small amount of methane. The methane in the atmosphere gives Uranus its blue-green color. Uranus is the first planet to have been discovered by telescope. It was discovered by William Herschel in 1781. Uranus has a very long year, taking about 84 Earth years to complete one orbit around the Sun. A day on Uranus is about 17.24 Earth hours long, with its rotation axis lying almost in the plane of its orbit around the Sun. Neptune. Neptune is a gas giant planet, composed mainly of hydrogen, helium, and methane, and is the farthest planet from the Sun in our solar system, with an average distance of 2.8 billion miles, 4.5 billion kilometers. It is tilted at an angle of about 47 degrees to the planet's rotation axis. Neptune has the strongest winds of any planet in our solar system, with speeds of up to 1,200 miles per hour, 2,000 kilometers per hour, and has 14 known moons, with the largest being Triton, which is the only large moon in our solar system that orbits in the opposite direction of its planet's rotation. Neptune's blue color is due to the presence of methane in its atmosphere, which absorbs red light and reflects blue light. Neptune has a ring system, although it is not well defined as Saturn's. A day on Neptune is only about 16 hours long, while a year on Neptune is about 165 Earth years long. Pluto. Our lovely abandoned Pluto. Pluto is a dwarf planet located in the Kuiper Belt, a region of the outer solar system that is home to many icy objects. It was discovered in 1930 by American astronomer Clyde Tombaugh. It was considered the ninth planet in our solar system until 2006, when the International Astronomical Union reclassified it as a dwarf planet. Pluto is very small, with a diameter of only about 1,400 miles, 2,377 kilometers, making it smaller than many moons in our solar system. Its surface is composed of nitrogen ice, methane ice, and carbon monoxide ice, with smaller amounts of water ice and other materials. Pluto has a very eccentric orbit that takes it from about 2.7 billion miles, 4.4 billion kilometers at its furthest from the Sun, to about 2.8 billion miles, 4.5 billion kilometers at its closest. Pluto has a thin atmosphere consisting primarily of nitrogen, with traces of methane and carbon monoxide. Pluto's surface features include mountains made of water ice, craters, and plains covered in nitrogen ice. Pluto takes about 248 Earth years to complete one orbit around the Sun, and a day on Pluto is about 6.4 Earth days long. Here's a couple of bonus facts about Pluto. Pluto has ice volcanoes. Volcanoes that spit up magma-like, lava-like, but it's made of ice. So Pluto has ice volcanoes. Some of the reasons that the international community was arguing on whether or not Pluto is considered a planet, one of the pros was that Pluto has tectonic movement on its surface, which creates these ice volcanoes. One of the cons, one of the things that the community says makes it not a planet and more like one of the icy objects from the Oort Cloud, is the fact that Pluto's orbit it crosses the orbit of another planet, which means that it's not part of the initial accretion disks that created the planets of our solar system. So there was the bang, creates a giant Oort cloud, all of the heavy materials are drawn back in towards the center, and then it created that accretion disk, and then everything kind of accumulated into the planets. Because Pluto's orbit is slightly tilted and shifted, it's not in line with the rest of the planets. That's one of the arguments as to why Pluto is no longer one of our planets, because it's not part of that initial accretion disk. It's off tilt. Additionally, it crosses the orbit of Neptune and spends a portion of its orbit or closer to the center of our solar system than Neptune. So just a couple more fun facts for you there. Pluto is the bastard child of our solar system. The Oort Cloud. Oort Cloud. The Oort Cloud is a cloud of icy objects that is believed to surround the outermost region of our solar system. It is named after the Dutch astronomer Jan Oort, who first theorized its existence in 1950. The Oort Cloud is believed to be the source of long-period comets, which have highly elliptical orbits that take them far beyond the orbit of Neptune and into the inner solar system. It is thought to extend from around 2,000 astronomical units to as much as 100,000 astronomical units from the Sun. Because the Oort cloud is so far away from the Sun, it is difficult to observe directly. Astronomers must rely on the indirect effects of its gravity on other objects to infer its existence. Estimates of the total number of objects in the Oort cloud range from several trillion to several quadrillion, and is thought to contain a wide variety of objects, including comets, planetesimals, and other icy bodies. The Oort cloud is so far away from the Sun that it takes around 200 million years for a single orbit. Despite its distance and difficulty of observation, the Oort cloud remains a fascinating area of study for astronomers who hope to learn more about the origins and evolution of the solar system by studying its icy inhabitants.
Mercury. Mercury is the smallest planet in our solar system with a diameter of just over 3,000 miles, or 4,800 kilometers. It's the closest planet to the Sun, and its surface temperatures can reach up to 800 degrees Fahrenheit or 427 degrees Celsius. Mercury has a very thin atmosphere, which means that there is no weather to speak of, and the planet's surface is exposed to space. Mercury has the shortest year of any planet, with a year lasting just 88 Earth days. Despite its size, it's the second densest planet in our solar system after Earth. Mercury has a long and interesting history with evidence of volcanic activity, tectonic activity, and impacts from asteroids and comets. Venus is the second planet from the Sun and often referred to as a morning star or the evening star because it is one of the brightest objects in the sky. Venus rotates in the opposite direction to most other planets, so the Sun rises in the west and sets in the east on Venus. Venus is often called Earth's sister's planet because of its similar size and composition to Earth. Venus is the hottest planet in the solar system, with surface temperatures that can reach up to 864 degrees Fahrenheit, or in real units, 462 degrees Celsius, due to its thick atmosphere that can trap heat. The atmosphere of Venus is mostly made up of carbon dioxide, with clouds of sulfuric acid that reflect sunlight and gives the planet its known yellowish appearance. Despite its proximity to Earth, Venus is one of the most difficult planets to explore due to its extreme temperatures on the surface, its thick atmosphere, and its harsh conditions that can quickly destroy any probe sent. Venus has no moons or rings, which makes it unique among the planets. Mars. Mars is often called a red planet because of its distinctive reddish appearance caused by iron oxide or rust on its surface. Fourth planet from the Sun, about half the size of Earth, has the largest volcano in the solar system called Olympus Mons, which is about 3 times taller than Mount Everest on Earth. Mars has the largest canyon in the solar system called Mariner Valley, which is more than 2,500 miles or 4,000 kilometers long and up to 7 miles or 11 kilometers deep. Mars has 2 small moons, Phobos and Deimos, which are thought to be captured asteroids. One of the main ways that Mars is different from the other planets in the solar system is its potential for life. Scientists believe that Mars may have had liquid water on its surface in the past, and there's evidence that it may still have liquid water underground. This has led to speculation that Mars may have had or still has microbial life. Additionally, Mars has a more Earth-like climate than other planets in our solar system, with a thin atmosphere that's mostly carbon dioxide but also contains small amounts of nitrogen and argon. The Moon. The Moon is the Earth's only natural satellite. It is about 1/4 the size of Earth. It's the 5th largest moon in our solar system. The moon's gravity causes tides on Earth, and its influence has been used for centuries to help people keep track of time and navigate. The moon is covered in craters, mountains, and valleys and has no atmosphere, no water, and no signs of life. The moon is slowly moving away from the Earth at a rate of about 1.5 inches per year. The moon is tidally locked to the Earth, which means it always shows the same face to us. The moon also has the same apparent size as the sun when viewed from the Earth.
Formation of the solar system. The 4 inner planets of the solar system, Mercury, Venus, Earth, and Mars, are rock since they formed close to the sun, where temperatures were high enough to vaporize lighter elements like hydrogen and helium. The only materials available were heavier elements such as iron, silicon, and oxygen, which are the building blocks of rocky planets. The formation of gas giants is impossible in these regions of the solar system. The outer planets of the solar system, past the asteroid belt, Jupiter, Saturn, Uranus, and Neptune, are gas or ice giants because they formed further away from the sun, where temperatures were low enough for lighter elements to condense and for ice to be more prevalent. These particles then clumped together to form the cores of the gas giants, which eventually accumulated hydrogen and helium gas around their cores. So the mass of the objects pulling it together, and it formed an accretion disk, and then as the things were spinning, it sucked them in and it made them into the planets.